Okay, today we're going to talk about the quadratic formula. Now, you may have learned the quadratic formula with a song. There's a lot of songs that this goes to, so if you enjoy singing, please YouTube it, Google it, whatever you got to do to find that, to memorize it. I am not going to sing to you because people don't watch these videos anyway, and if I started singing, I would get even fewer views than I already get. So, we're going to follow this formula here in purple, and so remember, it's a lot of people memorize it as negative b. The reason I say it's opposite of b is because if b is already negative, the opposite of that would be positive. So I say opposite of b plus or minus the square root of b squared minus 4ac, and it's all over 2a. So let's go ahead and plug this into our formula and see what we get. Well, first we need a, b, and c. So a is the number attached to x squared, so in this case that's 2. B is the number attached to x, so that is negative 7. And c is the number by itself, or the constant, which is positive 5. Over here, our a would be 7, b would be negative 10, and c would be negative 1. So just finding it in order, ax squared plus bx plus c. So a, then b, then c. All right, plugging into that formula. So the opposite of b is negative 7, so the opposite of b would be a positive 7. Plus or minus square root of b squared, so that would be negative 7 squared, minus 4, because that's part of the formula, times a, which is 2, times c, which is 5, and this entire thing is all over 2 times a, which is 2. So we just learned the discriminant, and how the discriminant was what was underneath the square root, that b squared minus 4ac. So you should at least be used to that, but now it's underneath the radical where before it was not. Let's simplify everything. So we have 7 plus or minus the square root. Now, simplifying this, negative 7 squared is 49, and then 49 minus 4 times 2 is 8, times 5 is 40. So 49 minus that 40 is going to give me the square root of 9. Now, you can put that in your calculator. Be careful. Just put it just as you see it. Don't include the square root, but parentheses, negative 7 parentheses squared, minus 4, parentheses 2, parentheses, parentheses 5, parentheses. When you hit enter, you should get 9. It's still under the radical. We didn't take the square root of that. And this is all over our 2 times a. So 2 times 2 is 4. Now, in this case, we can take the square root of 9. So if you can reduce the radical, please do it. So the square root of 9 is 3, so really we get 7 plus or minus 3 over 4. Okay, now I have all numbers. I have no i's there, I have no radicals left over, so I can actually solve this. And when you solve this, you want to write it up in your two solutions, 7 plus 3 over 4 and 7 minus 3 over 4. So let's go ahead and write that. So I'm going to get two answers. One answer of 7 plus 3 over 4, and then my other answer, 7 minus 3 over 4. So 7 plus 3 is 10, and so I get 10 over 4. If I put that in my calculator, 10 divided by 4, math, enter, enter, my final answer would be a positive 5 over 2. So that's one answer. 7 minus 3 over 4 is going to give me a 4 over 4. Well, anything divided by itself is 1, so I also get a positive 1. Now, why did we get two solutions? We got two solutions because our exponent is a 2. Whatever your highest exponent is tells you how many solutions you're going to get. That's why we have a plus or minus, because we get two solutions, one with the positive of all that with the quadratic formula, and one with the negative. It just turned out in this case, we had no radicals left over, no i's, so we could reduce this all the way down and find, hey, at 5 over 2, or at 2.5, it's going to cross the x-axis, and it's going to also cross the x-axis again at 1. So we have two real solutions. With the discriminant, our discriminant was 9, so that means because it's positive, something greater than 0, we knew we were going to have two real solutions. We just didn't know what those were, so now we know. Moving forward with number 2, another example. If I go too fast, you can pause, rewind. If you want to hear my beautiful voice one more time, that is a great idea. Go ahead and rewind. Here, opposite of b is already a negative 10. So the opposite of that would be a positive 10, plus or minus square root of b squared. So b is negative 10, right? b is negative 10, so b squared minus 4 times a, which is 7, and then times c, which is a negative 1. And this entire thing is all over 2 times a, which is 7. Now, we need to simplify or reduce what's under the radical, and that is technically our discriminant, and we'll be able to tell the nature of the roots from there. So we get 10 plus or minus the square root. So if you plug that in your calculator, be careful with the parentheses and the negative and the minus and all that jazz. But if you plug this in your calculator, you should get 100 plus 28. Well, 100 plus 28 is 128. And this is all over 2 times 7, which is 14. Okay, now, 128, kind of a larger number. We need to reduce that as a fraction. Here, we knew the square root of 9 was 3. Here, we don't know what the square root of 128 is, so we have to reduce this. First, we do know we're going to get 2 real solutions. We just don't know what they are. How we know that is because 128 is something larger than 0. So let's go ahead and out to the side, we're going to break down the square root of 128. Any even number is going to be divisible by 2. So 2 times 64 is going to get me back to 128. 2 is a prime number. However, what's interesting is we know the square root of 64 is 8. So we know that 8 times 8 is 64. Now 8 is not prime, but notice how I have a group or a pair of 8s here. So I actually don't have to go any further, because just like if you're playing the matching game where you put a bunch of cards in front of you and you flip one over and it's a pterodactyl and you flip one over and it's a T-Rex, well, those aren't a match, so you have to flip it back. And then next person flips over a T-Rex and like, ooh, I know where that is. They flip over this one and they're both T-Rexes. Well, here we have 2 cards that are the same. I have an 8 and another 8. Well, I take both cards with me, but I have 1 point because I have 1 match. In the same way, I'm going to take both of these 8 out of this 128, but I only have 1 group. I only have 1 8 that gets taken out. So what we're saying is here we have left over 8 radical 2. I had a group of 8s that I took out of the house, so out from underneath the radical, and I brought it outside. I have a 2 that's left over that did not have a match. It did not have a friend, so you have to stay home, play Call of Duty, or do something else. Therefore, the square root of 128 is 8 radical 2. They mean the same thing written in a different way. Just like if I said, hey, I have 50 cents, or I have half of a dollar. Well, 0.5, 50 cents, or 1/2 of a dollar, they're the same thing written in a different way. So these are equal to each other. So now we have 10 plus or minus, the square root of 128 is 8 radical 2, and this is all over 14. Now, unlike this one, where I only had numbers so I could find the answer, here I have a square root. So I really only have a couple more steps left that I can do. So what we're going to do is we're going to split this fraction. And we're going to take this part of the fraction, the leftmost part of my numerator, on the left side of the plus or minus, and the denominator, and write that as a fraction of 10 over 14. And then I'm going to take the right side of my numerator and the denominator, so plus or minus 8 radical 2 over 14, and I'm going to reduce each one individually. And look, it kind of makes a heart because you love math. Aw. So if I were to reduce 10 over 14, I get 5 over 7. So I get 5 over 7 plus or minus 8 radical 2 over 14. This square root is underneath, or I'm sorry, that 2 is underneath the radical. I cannot reduce a number under a radical with a number outside of a radical. So only 8, because it's on the outside, can be reduced with a 14 on the outside. 8 over 14 reduces to be 4 over 7. So this is 4 radical 2 over 7. Now, why are we writing it this way as 2 separate fractions? Because looking forward, as we start finding the vertex, this 5 over 7 right here, this is the x value of that vertex. So technically we're writing it this way because this shows me the x value of my vertex. And if I want to find the y value of the vertex, I would plug that in and find y. You don't need to do that yet, but this is just a skill that we'll need moving forward.